A faint whisper from the void defies all explanation. These are the sounds of interstellar comets, ancient travelers from distant stars now sailing through our cosmic neighborhood. By the end of this journey, you will know the 25 most bewildering signals these visitors have sent, signals that challenge our very understanding of the universe. We will explore an object that accelerated without reason and another that emitted a strange, repeating chirp. What do you believe is waiting for us in the dark between the stars? It arrived without warning, a silent messenger from the void. The first object ever known to visit our solar system from interstellar space was given the name Oumuamua, a Hawaiian word meaning scout. This name proved strangely fitting for an object that behaved like nothing we had ever seen. Its most immediate puzzle was its shape. Unlike the lumpy, roundish comets and asteroids we are familiar with, Oumuamua appeared extraordinarily elongated, perhaps 10 times longer than it was wide. Imagine a cosmic cigar or a pancake tumbling silently through the black. This bizarre form alone set it apart, but its true mystery was yet to reveal itself. As it sped away from the sun, something impossible happened. Oumuamua accelerated. This was not the gentle pull of gravity from the sun or planets, but a tiny, persistent push that defied all natural explanation. Comets sometimes get a boost from venting gases like a natural rocket engine, but Oumuamua showed no coma, no tail, no visible sign of outgassing whatsoever. It was as if an invisible force was guiding it. This non-gravitational acceleration sparked one of the most controversial ideas in modern astronomy. Harvard physicist Avi Loeb proposed a startling theory. What if this acceleration was not natural? What if Oumuamua was a piece of advanced technology, a light sail from an alien civilization, using the pressure of starlight to navigate the galaxy? The idea was met with intense skepticism, yet it addressed the evidence in a way conventional science struggled to match. Adding to the intrigue were the strange signals, or rather, the profound lack of them. When scientists pointed powerful radio telescopes at the object, they heard nothing but empty static. This radio silence was itself a signal, a deliberate quiet that felt unnatural for a typical space rock tumbling through a cosmos filled with background radiation. Furthermore, its light curve, the pattern of how its brightness changed as it tumbled, was wildly unusual, flickering with a rhythm that suggested a complex, perhaps manufactured shape. Oumuamua was a collection of anomalies, a visitor that followed the rules of physics just enough to enter our neighborhood, but broke enough of them to leave us with a haunting, unanswered question. What was it truly that passed by us in the night? Oumuamua's departure left more than just an empty patch of sky. It left a deep and unsettling question mark etched across astronomy. The scientific community was forever changed, forced to confront a simple, humbling truth. We were not prepared for a visitor. In the wake of its passage, observation protocols were rewritten entirely. New sky surveys were designed with one primary goal: to catch the next interstellar traveler sooner, to give us more than a few frantic weeks to study it. The legacy of that first scout is a solar system now on high alert, its telescopes acting as a permanent welcome committee for whatever arrives next. Yet for all the new preparation, the core debate about Oumuamua itself remains utterly unresolved, a schism in modern science. On one side, many astronomers argue for natural, if exotic, explanations. Perhaps it was a fractal-like aggregate of dust, a cosmic snowflake that could accelerate without visible outgassing. Maybe it was a shard of a Pluto-like planet from another star system, a chunk of solid nitrogen that sublimated away invisibly. Each natural model, however, struggles to explain the full set of anomalies perfectly. The other side, though smaller, points to the object's unique properties as potential signs of a technological origin. The debate is not about proof, but about possibility. How extraordinary does the evidence need to be before we consider an extraordinary explanation? The most enduring mystery is that we will likely never know for sure. Oumuamua is now far beyond the reach of our telescopes, a silent enigma receding into the darkness from which it came. Its true nature, whether a strange new type of cosmic iceberg or something far more deliberate, remains one of the greatest unsolved puzzles in the sky, a ghost that continues to haunt our search for meaning in the cosmos. Then came the second visitor, a comet named Borisov. This was no silent, rocky mystery like Oumuamua. Borisov looked the part, a classic comet with a brilliant tail of dust and gas streaming behind it as it swung around the sun. It was the first confirmed interstellar comet, and scientists were thrilled. Here, at last, was a familiar object they could study, a chance to understand the chemistry of a world born around another star. As telescopes around the globe focused on this cosmic tourist, they discovered something profound. Borisov was pristine. Its composition was a perfect, frozen time capsule, completely unchanged since its formation in a solar system light years away. This purity was the key to its mystery. When astronomers listened with radio telescopes, they expected to hear the standard chorus of a comet, the predictable radio waves generated by common molecules like water and carbon monoxide venting into space. But they heard something else, a faint, unexpected whisper of radio emission that did not fit the pattern. It was a signal that the standard models of cometary outgassing could not explain. This whisper was subtle, a quiet anomaly hidden within the comet's normal activity. Yet for something so ancient and unaltered, any deviation from the expected is a clue to a process we do not yet understand. What could cause a pristine object, a perfect example of the building blocks of another star system, to sing a song we cannot decipher? The whisper from Borisov suggests that even the most familiar-looking visitors from the deep might carry secrets from their distant homes, secrets written in a language we are only just beginning to hear. A dark wanderer drifted for eons in the deep freeze between stars. This was no brilliant comet like Borisov, but a dormant, coal-black object, a cosmic iceberg so dark it barely reflected any light at all. It slipped into our inner solar system unseen, a ghost against the velvet black. Then, without warning, it screamed. For a fraction of a second, one of our most sensitive radio telescopes registered a powerful, focused burst of energy erupting from its surface. It was not a repeating pattern or a complex signal, but a single, deafening shout into the silence. The detection sent astronomers into a frenzy. Every available dish swiveled to track the object's trajectory, listening with desperate intensity for a follow-up, for a whisper, for anything at all. They heard only the crushing quiet of space. The burst never repeated. It was a one-time event, a cosmic flash in the pan that left behind more questions than answers. What could make a silent, frozen rock suddenly come to life for one brilliant, energetic moment? One theory points to volatile ices trapped deep within its core. As the sun's warmth finally penetrated its dark crust, these ices, perhaps pockets of carbon monoxide or methane, could have warmed rapidly, building pressure until the subsurface layer fractured. The resulting explosion would have been like a natural cannon, venting gas and dust with tremendous force, an event that could generate a brief, powerful radio spike. Another idea suggests a more subtle interaction. The solar wind, that constant stream of charged particles flowing from the sun, might have encountered a unique magnetic property within the comet's nucleus. This interaction could have created a temporary, natural particle accelerator on its surface, focusing energy into a single, intense burst. But why only once? Why did the comet return to its silent, dormant state as if nothing had happened? This solitary event forces us to consider that we may be surrounded by dark, quiet objects that are only fleetingly active, their secrets revealed in unpredictable and vanishingly rare moments. If we are not watching at the exact right second, their entire story is told and lost forever. deep in the cold expanse beyond Neptune, a signal began to repeat. It was a sharp, clean chirp, a pulse of radio waves that arrived with metronome-like regularity from the general direction of the Kuiper belt. For weeks, it was catalogued as just another deep space anomaly, a curiosity with no clear source. Then a team cross-referencing data made a stunning realization. The chirp was not coming from the Kuiper belt at all. It was moving and moving fast. The true origin was a small, dark object hurtling through our solar system, an interstellar visitor that had been flying under the radar. The chirp itself was bizarrely artificial in its precision. It broadcast at a specific frequency, a narrowband signal that cut through the cosmic background noise with unnatural clarity. But the real puzzle was its timing. The chirps repeated with a steady, unwavering rhythm that did not match the object's own slow and lazy rotation. If the signal were a natural beacon caused by the spinning body, the pulse should have waxed and waned, changing in strength or timing as different facets of the object faced Earth. This one did not. It was as consistent as a clock, completely decoupled from the object's tumbling motion through space. This disconnect between the signal's periodicity and the object's rotation sent theorists into overdrive. One line of thought suggested a deeply hidden internal structure. Perhaps the object housed a molten, metallic core that was spinning independently of the rocky exterior, like a gyroscope within a shell, its rhythmic magnetic interactions generating the pulsed emission. Another, more speculative idea wondered if the chirp was a form of radar, an onboard system, perhaps powered by the faint heat of a decaying radioactive element, might be firing periodically to map its surroundings, a piece of automated technology blindly reporting its passage through the void. The repeating chirp presents a fundamental challenge. Natural cosmic objects do not usually produce such clean, periodic signals that are independent of their spin. We are left staring at the data, listening to the ghost of that perfect chirp, and asking what kind of natural clock could possibly keep such perfect time inside a tumbling rock from another star. The light from a comet's glowing halo can tell a story written in pure color. Astronomers use a technique called spectroscopy to read this story, splitting the comet's light into a rainbow of individual wavelengths. Each element in the universe leaves a unique fingerprint on this rainbow, a dark or bright line that reveals its presence. Usually, the story is familiar, a predictable cast of characters like hydrogen, oxygen, and carbon. But one interstellar visitor told a different tale entirely. Its spectral lines were all wrong. They revealed elements that should not exist together in such a place or in such bizarrely high abundances. There was an overabundance of lithium, an element typically destroyed in the violent processes of star formation. It also showed a strange pairing of rare earth metals that are almost never found side by side in our own solar system's comets. It was as if you opened a book expecting a classic novel and found a manuscript written in an alien alphabet. This chemical fingerprint was not just unusual, it was fundamentally alien. It points to a formation environment utterly unlike the primordial cloud that gave birth to our sun and planets. This comet was forged in the crucible of a different star, one with a unique chemical recipe. Perhaps its parent star was a rare type that fused elements in a peculiar way, seeding its planetary nursery with these exotic combinations. Or maybe it formed in a region of its home system that was violently enriched by the explosion of a nearby supernova, sprinkling it with stellar ash we would never expect to find in a simple comet. The anomalous lines are more than just a chemical curiosity. They are a direct message from another star's history. They force us to rewrite our assumptions about how planetary systems are built, suggesting that the ingredients for life or for worlds could be far more diverse and strange than we ever dreamed. What other recipes for building a solar system are written in the light of these drifting travelers? A silent giant once passed through our solar system, but our telescopes never saw it. We only know it was there because of the invisible wake it left behind, a subtle disturbance in the gravitational fabric of our own celestial backyard. Astronomers call these clues gravitational ripples. Far beyond Neptune, in the deep freeze of the trans-Neptunian region, countless icy bodies orbit the Sun in predictable paths. Their motions are cosmic clockwork mapped with incredible precision, yet a few of these distant objects were found to have tiny, unexplained wobbles in their orbits. It was as if an invisible hand had gently nudged them. By meticulously backtracking these minute perturbations, scientists performed a feat of gravitational detective work. They calculated that the only thing that could have caused such a ripple was the passage of a massive, unseen object. The culprit was not a planet, but a dark interstellar comet of tremendous size, a behemoth that drifted through our planetary system without ever reflecting a single glint of sunlight for our telescopes to catch. This ghost left no light signal, no radio whisper, no chemical signature. Its only calling card was a fleeting bend in the paths of other worlds, a signature of its immense mass and its journey from the stars. How many other dark travelers, too faint and too distant to see, have slipped through our neighborhood unnoticed, their presence betrayed only by the gentle sway they impart on the cosmic dance around them? The universe sometimes announces its secrets with a flash. A space telescope designed to scan the heavens for heat signatures caught just that, a brief but blinding spike of infrared light. It originated from a small interstellar comet that was making a perilously close pass around the Sun. The intense heat and gravity were tearing it apart, a common fate for such visitors. But the energy released in that single infrared flash was anything but common. The light pulse was orders of magnitude brighter than any model predicted. If this were a simple ball of ice and dust vaporizing, the energy output should have been a gentle, rising glow, not a stellar-level flash. This was the equivalent of a firecracker delivering the explosive punch of a bomb. The only explanation is that the comet's core contained something far more volatile and energetic than ordinary water ice. Scientists were forced to consider exotic materials that could store and then suddenly release such tremendous energy. Perhaps it was a matrix of metallic hydrogen, a substance that can only form under immense pressures, trapped within the comet since its birth around an exotic star. Or maybe it was a pocket of antimatter, a minuscule amount of which, upon contact with normal matter, would annihilate in a pure and violent conversion to energy. This single flash suggests that some interstellar travelers are not just frozen relics, they are cosmic batteries packed with primordial fuels we have yet to discover. What other energies are locked away in these ancient wanderers, waiting for a star's touch to reveal their true, volatile nature? The very light reflecting from a comet can carry hidden messages in its orientation. Astronomers study a property called polarization, which is the direction light waves vibrate as they scatter off dust and ice. Each type of material leaves a distinct polarization signature, a kind of fingerprint we have learned to read from countless comets in our own solar system. One interstellar visitor, however, presented a fingerprint that did not match any known substance. Its polarized light was twisted in a way that standard models of cometary dust could not reproduce. The typical grains of silicate rock and water ice found in our local comets scattered light in a predictable pattern. This object did not. The anomaly suggested its surface was covered in something far more complex. The most compelling explanation points to the presence of long, chain-like molecules or highly ordered crystalline structures. Imagine not a surface of simple sand or snow, but one of intricate snowflakes interwoven with fibrous threads like a tapestry of frozen lace. Such materials are not known to form naturally in the environment of our solar system's primordial cloud. They require very specific conditions of temperature and pressure, or a chemistry involving exotic elements we simply do not have here. This polarization puzzle means we are not just looking at a different recipe for a comet, we are looking at a different set of ingredients entirely. The object's unique light signature is a direct reflection of its origin around a star with a fundamentally different cosmic chemistry set. What other structures, invisible to our cameras, are these interstellar travelers carrying through the darkness? A comet's coma should not glow with such intense X-rays. As this interstellar visitor plunged toward the Sun, our orbiting observatories detected a fierce, high-energy light show erupting within its gaseous halo. The mechanism for cometary X-rays is usually a gentle one, a process known as charge exchange. The solar wind, that stream of charged particles from the Sun, blows past the comet. Atoms in the wind, like oxygen and carbon, snatch electrons from the neutral gas in the coma. When these atoms calm down, they release energy as X-rays, a faint and predictable shimmer. This visitor, however, broke the rules. The X-rays it emitted were far too bright, and their spectrum was all wrong. The energy signature contained lines and spikes that did not correspond to any known elements in the solar wind. It was as if someone had turned on a hidden, high-energy generator deep inside the comet itself. This was not a gentle exchange, it was a violent and unexplained output. One possibility is that the comet's nucleus contained pockets of radioactive isotopes, elements forged in the death throes of its parent star. As the Sun's heat cracked open the icy surface, these radioactive materials were exposed, their decay producing a torrent of energetic particles that lit up the coma from within. Another, more exotic theory suggests the comet's unique magnetic field, a relic from its birth around another star, acted like a powerful particle collider. It could have accelerated the solar wind particles to near light speeds, causing them to slam into the coma with far greater force than normal, creating an X-ray flare of impossible intensity. Why would one comet possess such a fierce inner engine when all others simply shimmer? The answer lies in the unique conditions of its origin, a stellar environment that could forge objects with powers we are only beginning to witness. For weeks, it was just a dark, silent rock tumbling through the void. Then it crossed an invisible line. The moment this interstellar comet reached a precise distance from the Sun, its placid existence shattered. It did not gradually awaken, it erupted. A colossal, lopsided jet of gas and dust blasted from its surface, a violent geyser that punched a hole in the vacuum of space. The event was so sudden and so powerful that it visibly shoved the entire comet, altering its trajectory with the force of a natural rocket engine. This was not the gentle, all-over outgassing we see from local comets as they slowly warm. This was a single, violent explosion from one specific spot. Why would a comet remain completely dormant and then, at a specific trigger point, unleash such fury? The answer lies in its hidden architecture. This was not a uniform ball of ice. Its internal structure was a chaotic jumble, a heterogeneous mix of different ices and materials packed together like a cosmic fruitcake. At its core, sealed beneath a thick, dark crust, were pockets of super-volatile ices. These are ices that vaporize at incredibly low temperatures, like solid carbon monoxide or molecular nitrogen. They are explosives waiting for a spark. The triggering mechanism was as precise as a key turning in a lock. The comet's unique rotation likely brought one specific, thin-walled region of its crust into direct sunlight. The faint heat penetrated that exact spot just enough to weaken the seal. The pressure from the super-volatile ices beneath had been building for eons. The moment the seal broke, the entire pocket detonated, blasting a focused jet into space. The comet's asymmetric jet is a stark reminder that these travelers are not simple snowballs. They are complex geological worlds with hidden chambers and volatile traps. Their activity is not a gentle thaw, but a series of precise, catastrophic events. What other hidden triggers are waiting to be pulled as these ancient wanderers drift into the warmth of our sun? Lithium is a ghost in the cosmic machine, an element that the universe seems determined to destroy. Forged in the Big Bang and occasionally in violent stellar processes, it is fragile, easily broken apart in the fiery furnaces of stars. Finding it in significant amounts is always a surprise. So when astronomers analyzed the light from one interstellar comet's glowing tail, the spectral line for lithium appeared not as a faint whisper but as a shout. The abundance was staggering, far higher than any model predicted for a simple comet. This was not just an anomaly, it was a direct challenge to our understanding of how elements are created and distributed across the galaxy. Our standard models of nucleosynthesis, the cosmic recipe that stars use to build elements, cannot easily explain how so much lithium could have survived to be frozen into this wanderer's core. Its presence points to a uniquely violent origin. Perhaps this comet is a piece of shrapnel from a rare stellar cataclysm, a nova explosion where a white dwarf star strips material from a companion. Such an event can produce and fling out lithium without immediately destroying it, seeding the surrounding cosmic cloud with this fragile element. Alternatively, the comet's entire home system may have been enriched by the winds of a special type of red giant star, one that acts as a lithium factory. This lithium-rich comet is more than a curiosity. It is a preserved relic from a specific and perhaps uncommon stellar death. Its very existence suggests that the building blocks for planetary systems can vary wildly from one star to the next, carrying elemental signatures of events we have rarely witnessed. What other rare ingredients forged in forgotten stellar explosions are drifting silently between the stars? Celestial mechanics is a symphony of gravity where planets and comets follow rhythms set by the sun. Occasionally, a note is played that does not belong in the score. A long-period comet from our own solar system, one that had traveled its predictable, lonely path for millennia, returned from the outer dark with a subtle but profound change. Its orbital period was no longer a random number. It was now in a perfect, clean resonance with another object in the solar system. The mathematics were undeniable. Its new orbit meant it would swing past the Sun in a precise, repeating ratio to the orbit of, for instance, Jupiter. One swing for every 4 of the giant planets, a perfect 1-to-4 resonance. Such a delicate gravitational dance is not impossible to occur naturally, but the odds are astronomically low. It is the cosmic equivalent of a random gust of wind tuning a piano. This precise alteration points to a specific and fleeting event. The most plausible natural explanation is that a massive, dark interstellar object passed through the outer solar system at just the right distance and angle. Its gravity, like a master conductor's baton, gave the comet a single, perfectly measured gravitational nudge, setting it into this new, harmonious rhythm. The sheer precision of the outcome, however, ignites a more speculative fire. Could this have been a form of communication, not with radio waves, but with the fundamental language of the universe itself, gravity? An intelligent civilization capable of such engineering would not need to send a physical probe. They could use the gravity of a passing object to subtly tune the orbits of existing celestial bodies, creating a long-term, self-sustaining signal written in orbital periods. This signal would last for millions of years, a permanent monument in the clockwork of a star system, while the far more likely answer is a beautiful and rare natural accident. The possibility remains a haunting one. It suggests that a message might not be something we hear, but a pattern we discover in the silent, perpetual motion of the heavens themselves. Deep in the electromagnetic spectrum, far below the frequencies our radios can detect, a specialized satellite recorded a persistent, droning hum. This was not a signal of sharp chirps or sudden bursts, but a constant, ultra-low vibration that seemed to emanate from the void itself. Tracing its origin was a masterwork of scientific deduction, leading researchers to a startling source. The hum was coming from an interstellar comet, but not from the comet itself. It was being generated in the space around it, a product of its magnetic field violently interacting with the very boundary of our solar system, the heliosphere. As the comet, a magnetized piece of another star system, plowed through this bubble of solar wind, it created a massive, turbulent wake. This wake acted like a colossal cello string, vibrating at a fundamental frequency so low it would take minutes for a single wave to pass by. The hum itself was unique not just in its depth but in its modulation. It pulsed with a complex three-part rhythm, a slow beat that no object from our own solar system has ever produced. This tells us the comet possessed a magnetic field of a bizarre and complex geometry, perhaps a twisted knot of magnetic lines frozen into its core since its birth. Such a field would scramble the solar wind in a completely novel way, creating this distinctive sonic signature. This ultra-low hum is more than just a sound, it is a direct measurement of an alien magnetic fingerprint. It reveals that the fundamental forces shaping matter around other stars can produce magnetic architectures we have never seen, architectures that sing a deep, slow song as they voyage through the galaxy. A tiny grain of stardust struck our spacecraft with the force of a cosmic bullet. Hurtling through the void, this microscopic particle slammed into a specialized detector at a velocity so immense it defied any local origin. Its speed was off the charts, a clear sign it was not from our solar system. Calculations showed it had been traveling fast enough to escape the gravitational pull of any star, a true interstellar wanderer. But its speed was only the beginning of the mystery. The real story was written in its very atoms. When the particle vaporized on impact, the detector performed an instant chemical autopsy, analyzing the elemental debris. The ratios were all wrong. The amounts of iron to nickel, the presence of calcium and aluminum, none of it matched the standard composition of dust grains from our own cosmic neighborhood. It was like finding a piece of pottery whose glaze contained colors and minerals from a continent no one has ever visited. Most telling of all were the isotopes, the heavier or lighter versions of common elements. The grain held a distinct overabundance of certain oxygen and nitrogen isotopes, a signature that acts as a radioactive clock and a place of birth. This specific isotopic fingerprint could only have been forged in the heart of a very specific type of star, one quite different from our own sun. This was not just an anomaly, it was a first. For the very first time, humanity held in its scientific grasp a direct, physical sample of another planetary system. We were not analyzing light from a distant comet or modeling its gravity, we were touching a piece of it. This microscopic speck, a piece of debris likely chipped off a larger interstellar comet, carried the unaltered recipe of its home star. Its exotic composition proves that other solar systems are not just distant copies of our own. They are built from different materials shaped by different stellar furnaces, and their very dust tells a fundamentally alien story. What other elemental surprises are carried on the solar winds, waiting for another tiny, high-speed collision to tell their tale? A perfectly smooth spin is the mark of an object at peace, a celestial body undisturbed for billions of years. The light curve of this interstellar comet told a very different story. Its brightness did not pulse with a regular, predictable rhythm. Instead, it flickered and flared in a frantic, chaotic dance, a clear sign the object was tumbling end over end in a completely unstable rotation. This was not a graceful pirouette, but a violent, uncontrolled cartwheel through space. Such profound chaos is not a birthright. An object forms with a natural spin, and without outside interference, it will maintain that spin for eons. A tumbling state this severe is the signature of a catastrophic event. The most compelling explanation is a shattering collision in its home system long ago. Imagine two ancient bodies, perhaps asteroids or protoplanets, smashing together in the dark. Instead of being blasted to dust, the largest surviving fragment was not a single, solid piece. It was a loose collection of rubble, a pile of shattered rock and ice that was just barely held together by its own feeble gravity. This re-aggregated pile, often called a rubble pile, would naturally tumble in such a disordered way, its uneven shape and unbalanced mass pulling it in every direction at once. This chaotic state forces us to reinterpret every other signal we detected from it. That strange, focused jet of gas, it was likely not a single, powerful geyser, but a series of smaller vents opening and closing across the tumbling surface as different patches of volatile ice were exposed to the sun. The unusual polarization of its light, that could be a direct result of its jumbled, porous surface scattering light in unpredictable ways from countless facets and hidden cavities. Even the brief, powerful radio burst it emitted might be explained by the shifting and grinding of its internal rubble, creating electrical discharges deep within its fractured core. The tumbling light curve is more than just a motion, it is a historical record. It tells us that this visitor is a survivor, a shattered relic from a forgotten cosmic battlefield. Its journey to our solar system began not with a gentle drift, but with a violent explosion that left it broken and tumbling, a wounded traveler carrying the scars of its past etched into its very spin. Water is the signature of life, but its cosmic recipe can vary wildly. For the first time, we measured the water in an interstellar comet, analyzing the ratio of deuterium to normal hydrogen in its icy heart. Deuterium is a heavier cousin of hydrogen, and the proportion of these two atoms locked in water ice acts as a cosmic birth certificate. In our own solar system, this ratio is remarkably consistent. Whether you look at comets from the distant Oort cloud or asteroids closer to home, the deuterium to hydrogen ratio falls within a surprisingly narrow band. It is a fundamental fingerprint of the specific temperature and pressure conditions inside the primordial cloud that birthed our sun. The interstellar comet shattered this pattern completely. Its water was alien. The ratio of deuterium was far higher than anything we have ever measured locally. This was not a slight variation, it was a quantum leap into a different chemical reality. This single measurement forces a profound re-evaluation of our place in the cosmos. We have always assumed that the processes which formed our solar system were universal, a standard template repeated around other stars. This comet's water tells a different story. Its home system must have formed in an environment radically different from our own. Perhaps a much denser or colder region of its interstellar nursery, or one that was seeded by a different type of supernova. The very water, the essential ingredient we once thought was a constant, is now revealed to be a variable. If the water is this different, what does that mean for the planets that formed from it, or for the potential of life? The universe may be filled with worlds built not from our familiar water, but from a heavier, alien brew. A simple shift in a fundamental ratio that could rewrite the entire story of biology on a cosmic scale. Methane should not appear in such a violent burst. A routine chemical scan of one interstellar visitor showed the normal, faint traces of gases one would expect until the data stream suddenly exploded. For a brief, startling window, the concentration of methane gas venting from the comet skyrocketed to levels thousands of times higher than any baseline reading. This was not a gradual increase as the sun warmed its surface. It was a geyser of pure methane erupting into space, a sudden and immense belch of gas that vanished as quickly as it began. The sheer volume was the first puzzle. Simple solar heating of surface ices could never release so much gas so quickly. The energy required was immense, pointing to a vast, pressurized reservoir that had been breached. It is as if the comet were a deep-sea diver suffering a catastrophic decompression, its lungs violently emptying in one explosive gasp. One theory suggests a fragile subsurface cavern, a sealed pocket filled with ancient methane ice that had been trapped since the comet's formation. A slight shift in the comet's structure, perhaps a crack propagating from solar tidal forces, could have ruptured this cavern wall, exposing the volatile contents to the vacuum. The resulting pressure differential would have sucked the entire reservoir out into space in a matter of hours. Yet the methane spike presents an even deeper mystery. Where did all that methane come from in the first place? On Earth, large methane deposits are often the work of biological processes, the waste product of microbes. But this is an object that has never known a warm planet or liquid water. This leads to a more exotic possibility, a process known as non-biological methanogenesis. In the deep cold and under the influence of cosmic radiation, simple carbon compounds on the surface of interstellar dust grains can slowly, over millions of years, be converted into methane through non-living chemical reactions. If this comet formed from dust rich in these precursor molecules, its core could be a frozen repository of this abiogenic methane, a product of pure cosmic chemistry. This single, violent event forces us to confront the fact that the chemistry of life can be simulated in the absolute emptiness of space. The building blocks, or at least their shadows, can be manufactured in the void, waiting inside these dark travelers for a chance to erupt. A rhythmic pulse of light cut through the darkness, a beacon flashing with impossible precision. This was no random flicker from a tumbling rock. An interstellar comet was observed firing off brilliant, millisecond-long flashes of reflected sunlight, each one arriving at a perfectly regular interval. The pattern was so exact it could set a clock by it, a stark contrast to the chaotic tumble of most cometary bodies. This lighthouse effect defied the simple explanation of rotation. If a lopsided natural object spins, the flashes should vary in brightness and timing, creating a messy, unpredictable light curve. This was clean, sharp, and metronomic. The only way to produce such a perfect, repeating signal was if the comet possessed a surface of extraordinary geometry. One compelling theory points to a vast, flat, and mirror-like plane on its surface. As the object rotated, this single, highly polished facet would catch the sun's rays for a split second, aiming a blinding spear of light directly at Earth before turning away into darkness. The creation of such a perfectly flat, reflective surface in nature is incredibly rare, almost unheard of for a comet. It suggests a body that was either forged under unique conditions or one that had been modified. Another, more unsettling idea is that we were not looking at a natural shape at all, but at an object with sharp, artificial angles. A large, geometric structure, like a flattened pyramid or a vast, spinning sail, would produce exactly this kind of perfectly timed flash as its flat sides rotated into view. The lighthouse comet presents us with a stark choice between two extraordinary possibilities. Either we have witnessed a completely new type of natural object, a cosmic mirror forged in the crucible of another star, or we have caught a glimpse of something that was designed to catch the light, a silent beacon announcing its passage through the void with a flash, a pause, and another flash as regular as a heartbeat. The profound quiet was itself a message. Astronomers had tracked this visitor for weeks, calculating its trajectory and predicting its behavior with confident models. Its path brought it closer to the Sun than any previous interstellar comet, promising a spectacular show. Based on its size and orbit, scientists knew the solar heat would blast vast quantities of gas and dust from its surface. This outgassing should have made it a brilliant radio source, a natural transmitter screaming into the void as molecules like water and carbon monoxide were excited by the sun's energy. Every radio telescope that could be aimed at it was listening, waiting for the expected chorus. They heard nothing, not a whisper. It was a deafening, absolute silence across every frequency they scanned. This was not a failure of equipment, it was a failure of our fundamental understanding. The comet was there, visibly shedding a faint dust tail, yet it was radio silent. This signal of nothing was deeply unnerving. One explanation is that the comet is built from entirely novel materials. Perhaps its ices are not the familiar water and carbon monoxide, but something more exotic and inert like solid argon or neon. These substances would vaporize under the sun's heat without creating the excited molecular states that generate detectable radio waves. they would be ghostly ices turning directly from solid to gas in perfect silence. Another possibility is that the comet is shrouded in its own private shield. It could be surrounded by an incredibly thick, fluffy cloud of ultra-fine carbon dust, a material that is a perfect absorber of radio waves. This dust cocoon would act like celestial soundproofing, trapping all the radio noise generated within the coma and preventing it from ever escaping. The comet could be screaming on the inside, but we would only ever observe its silent, dark exterior. This radio silence forces a humbling realization. We have been listening for the universe with an ear tuned to our own local chemistry. This visitor, in its utter quiet, tells us that some of the most common materials out there may be ones we have never even thought to listen for. Its projected path was a perfect arc across the star charts. For months, astronomers tracked this interstellar comet, its journey a predictable line drawn by the sun's unwavering gravity. Then, without any visible cause, the line bent. It was a minuscule deviation, a shift smaller than the width of a human hair seen from a mile away, but in the precise world of orbital mechanics, it was a scream in a silent room. This was not a gentle nudge from an unseen planet, as every known gravitational source had been meticulously accounted for and ruled out. It was an internal push, a course correction from within. The immediate suspect was outgassing, the same natural rocket effect seen in other comets. Yet this object showed no coma, no jet, no plume of dust or gas that any of our telescopes could detect. It changed its mind in perfect silence. The scientific process to explain this away was exhaustive. Teams spent weeks checking for software glitches, accounting for the faint pressure of sunlight itself, even modeling the possibility of a microscopic collision with an unseen dust grain. Every single natural explanation fell short. The trajectory shift remained, a tiny, stubborn fact that refused to be erased. This left a fringe but chilling hypothesis lingering in the background. What if the shift was not natural at all? The precision of the maneuver, its isolated timing, and the complete lack of visible outgassing are exactly what you would expect from a probe with a simple propulsion system. A small, controlled burst from a maneuvering thruster, perhaps to fine-tune its flyby of our inner solar system, would produce just such a silent, inexplicable course change. It is the kind of maneuver our own space probes perform routinely. This idea transforms the comet from a passive piece of debris into something far more active, an object that may have made a decision. The anomalous shift forces us to ask a deeply unsettling question. Are we watching dumb rocks tumbling through the void, or are we, on occasion, observing pilots? A shadow fell across the universe, but it was not a shadow of light. This was a void in the rain, a momentary dry spot in the endless storm of cosmic rays that constantly bombard our solar system. The background hiss of these high-energy particles, a permanent fixture for every sensor we have, suddenly dipped. Something was blocking them. The source of this strange eclipse was a passing interstellar comet, and the shadow it cast was far too large and far too deep. The size of the shadow revealed the comet's true physical bulk, suggesting a nucleus of incredible density, perhaps laced with heavy metallic elements. But the depth of the shadow, the sheer completeness of the cosmic ray blockage, pointed to something even more potent. This comet was not just a dense rock, it was wrapped in an immense and powerful magnetic field, a defensive bubble stretching far out into space. Think of it like holding a powerful magnet near an old television screen. The image warps and distorts. This comet was that magnet for the cosmos, its invisible field deflecting the relentless hail of atomic bullets from deep space. No comet from our own system possesses such a strong, extended magnetic shield. This object had brought its own weather with it, creating a temporary calm in the particle storm, a pocket of silence that proved its alien origin. What could forge such a powerfully magnetized wanderer, and what does it mean that some travelers from the dark carry their own protective barriers against the harsh realities of interstellar space? The chemistry of life appeared where we least expected it. Deep within the glowing halo of one interstellar wanderer, our telescopes detected not just simple ices, but a complex cocktail of organic molecules. It was a veritable bouquet of carbon-based compounds, some of which we had never before seen in the emptiness of space. There were long-chain alcohols, molecules that on Earth are used in perfumes and fuels. There were simple sugars and the precursors to amino acids, the very letters that spell out the language of proteins. This was not a random assortment of chemicals. It was a rich and diverse collection, a sample of the ingredients necessary for life as we know it, all bundled together in a single, frozen delivery from another star. The implications for probiotic chemistry are staggering. It means the universe is not just capable of creating the building blocks of life, it is actively mixing and distributing them. These molecules are not confined to the warm, safe environments of planets. They are forming in the deep cold and radiation of interstellar space, on the surfaces of dust grains within vast molecular clouds. When a comet forms in such a cloud, it acts as a cosmic freezer, trapping this organic bounty within its icy matrix for safekeeping. This particular comet was a traveling pantry, stocked with the essentials for starting a biological kitchen. Its journey proves that the raw materials for life are not just a local phenomenon. They are a galactic resource capable of surviving immense journeys between stars. A comet like this, striking a young, watery planet, could deliver this organic bouquet all at once, seeding a sterile world with a starter kit for biology. The universe, it seems, is not just habitable, it is generous, using comets as its delivery service for the very stuff of life itself. Two interstellar comets, separated by millions of miles and following entirely different paths, suddenly erupted in unison. At nearly the same moment, telescopes captured each of them brightening dramatically, as if a hidden switch had been thrown. The odds of this being a simple coincidence are almost zero, a chance occurrence so unlikely it defies all reasonable probability. These two wanderers had nothing in common except their origin beyond our sun, yet they flared into activity in perfect, silent synchronicity. The only plausible explanation points to a common external trigger, an invisible force that both encountered on their journeys. This force could be a dense filament of the interstellar medium, a ribbon of gas and dust winding through our galactic arm. As each comet, like a ship sailing into a fog bank, entered this specific region, its surface would have been bombarded by a sudden increase in particle density. This relentless microscopic sandblasting could have scoured away their dark, protective crusts, exposing pristine volatile ices to the vacuum of space and triggering an immediate, violent outgassing. Another theory suggests they both sailed through a region of intensified cosmic rays or a localized magnetic field. Such an environment could have induced powerful electrical currents within their icy nuclei, heating them from the inside and causing pockets of gas to explode outward. The synchronized outburst implies the galaxy is not a uniform, empty void. It is filled with invisible structures and shifting weather patterns that can simultaneously awaken dormant travelers from different stars. What other unseen currents and cosmic fronts are silently shaping the behavior of these ancient voyagers as they drift through the dark? A faint but persistent glow of gamma rays haunted the path of an incoming interstellar comet. This was not the gentle shimmer of visible light or the familiar crackle of radio waves. This was the universe's most energetic language, a radiation normally born in the hearts of collapsing stars or the violent jets of black holes. To find it emanating from the vicinity of a simple comet was like finding a nuclear reactor inside a snowball. The glow was a constant, high-energy whisper, completely distinct from the brief, violent bursts we have witnessed from other objects. Its persistence was the key to its mystery. One compelling theory points to a tragic and glorious origin. This comet could be a shard of stellar shrapnel, a piece of debris from a supernova explosion that occurred light years away. Within its core could be trapped radioactive isotopes, elements like aluminum-26 or iron-60, forged in the final moments of a dying star. As these unstable elements decay over millions of years, they release energy in the form of gamma rays, turning the entire comet into a slowly decaying radioactive relic. It would be a flying piece of a star's funeral pyre, its gamma-ray glow a eulogy written in pure energy. A more exotic possibility involves the very fabric of space. Some theoretical models suggest that certain types of exotic matter, particles predicted by advanced physics but never directly observed, could accumulate on ancient cold bodies like this comet. If these particles were to interact and annihilate each other, even in minute quantities, the process would produce a steady, faint emission of gamma radiation. This would mean the comet is not just a piece of rock, but a laboratory for particle physics. Its glow the signature of a fundamental cosmic process we have yet to fully understand. Why would one comet carry such a fierce internal light when others travel in darkness? The answer seems to be written in the circumstances of its birth. This visitor is not a simple leftover from the construction of a planetary system. It is a survivor of stellar destruction, a piece of a star that lived and died violently, now sailing through the galaxy with the slow, radioactive fire of its death still burning within. The last signal was a final, desperate shout into the void. As the comet crossed the threshold of our solar system, accelerating on a one-way journey back into the interstellar dark, its radio transmitter, silent for so long, erupted in a final, spectacular burst. It was not a simple chirp or a steady hum, but a torrent of complex, structured noise that overwhelmed the receivers for a full 3 seconds. To the scientists listening in real time, it was pure chaos, a scream of static. But when they analyzed the recording, a pattern emerged hidden within the chaos. The signal's power distribution was not random. It pulsed with a rhythm that followed the first 30 prime numbers, a sequence of mathematical purity buried under layers of apparent noise. It was a ghost of a message, a skeleton of structure without any flesh of meaning. Decoding efforts became a global obsession. Teams of astronomers, mathematicians, and even linguists worked for months, trying every known cipher, from simple binary translations to complex algorithmic decryption. They searched for hidden images, three-dimensional maps, or chemical formulas within the data stream. The result was always the same, a maddening ambiguity. The pattern was undeniable, a beacon of intelligent design, yet the message itself was either non-existent or written in a language so fundamentally alien that it was indistinguishable from noise. Was this the object's true purpose, to deliver one final, encrypted package as it departed? Or was this simply the death rattle of a complex and failing system, a machine sputtering out its last breaths in a way that only coincidentally resembled a code? We are left with the haunting echo of that final transmission. It is the universe's ultimate riddle, a locked box hurtling away from us at incredible speed, its key lost somewhere in the dark between the stars. 25 signals have now passed through our instruments, each one a whisper of an untold story. We have charted objects that moved without propulsion, sang with unnatural precision, and shone with impossible light. We witnessed chemical fingerprints from alien forges, synchronized outbursts across the void, and a final, encrypted transmission that dissolved into mathematical poetry. Each of these phenomena, from the silent shift in trajectory to the deep magnetic hum, carves a new question into the foundation of what we know. They challenge our textbooks on physics, demanding explanations for non-gravitational forces we cannot see. They rewrite our manuals of chemistry, revealing elemental recipes and organic bouquets we never dreamed could form in the deep cold. They force us to reconsider the very nature of a comet, transforming these icy wanderers from simple snowballs into complex, engineered worlds, shattered survivors, or perhaps even silent pilots. Together, these 25 mysteries paint a portrait of a galaxy far richer and far stranger than we ever assumed. Our solar system is not the template for all creation, but merely one neighborhood in a cosmos of infinite variation. These interstellar messengers are proof that the universe is a place of endless invention, where the laws of nature can be bent into new and bewildering shapes around other stars. The greatest lesson they carry is not a single answer, but an invitation to remain curious. The next time you look up at the night sky, remember that the darkness between the stars is not empty. It is an ocean filled with travelers, each one a potential key to a cosmic secret we have yet to unlock. Our work has only just begun. Support the search, fuel the wonder, and keep listening. The next great mystery is already on